Good afternoon, everybody. This is Corey Pieper. First, I should check if my cohorts are out there. I heard Joe before. Brian, are you out there as well?
Yes, Corey, I'm out there. Can you hear me good?
Yeah, I can hear you okay. How about me? My voice is blasting back into my ear. I sound really loud.
You sound fine.
Okay, cool. All right, well, I am running a little bit late, so I guess we'll go ahead and kick this thing off. You're here to see an introduction on QGIS, and you can see the presenters there below. Myself, I'm Corey Pieper from Southern Region Headquarters, and then following me will be Joe Moore from Goodland, Kansas, and Brian Wallawender from Central Region Headquarters, excuse me. So, let's see, I guess it would be good for you all to see my screen. Is it showing up now?
All good here.
All right, very good. So we've got a brief outline here. I'm going to be covering the first couple of topics, just a little bit about QGIS, a little bit about the Open Source Geospatial Foundation, what sort of platforms this software can run on, and then Joe's going to be doing a couple of brief demonstrations as to what QGIS can do, and then Brian's going to take a look at some of the data out there that's available, the Print Composer, and then we'll take a look at taking some questions from you all as to what your thoughts are and what you'd like to see us do in the future. The issue of what you'd like to see us do in the future is probably the most important part, because this, like I said, is just an introduction. Why are we doing this? Several years ago, well, 4 or 5, seems like several, I started doing a lot more work on Linux and Macintosh, Mac machines, and I really ran out of options as to where to go with regards to GIS software to do, simple editing of shapefiles and some visualization and things like that. And Brian Wallawender, who is one of the presenters here, he asked if I'd ever heard of QGIS, and I hadn't, and I gave it a spin, and I haven't been able to go back. It's pretty awesome. It does well, we'll get into what it does, but it's been something I've used pretty much daily for several years now. As we go through here, we're going to be pretty high-level stuff here. It's just an introduction to QGIS, but Brian and Joe and myself have a little bit of a training plan here, depending on how this goes and what sort of things that you all would like to see us do. And obviously, this first step is this training. And again, it's going to be pretty high level, so we're not going to get into the nitty-gritty of hows and whats and things like that with QGIS. But beyond this, we plan on doing a couple different things. And one is providing some what we're calling bite-sized video training, so maybe 4 or 5, maybe a little bit longer-sized minute videos that'll just show you how to do different types of things, different manipulation with shapefiles, rasters, things like that. So you can jump in, jump out, and maybe get an idea of how to do a particular thing if you're looking at a project and want to get a quick snapshot of some information. We're going to be posting all this information on the NOAA GIS Community Google site, and the address is down there. It's long, it's hairy, but really the best part for you all to remember, if you're going to be writing this down, and we can show it at the end again, is that very end part. So the GIS Community /software/open source, because all the other Google sites and the weather service have that same beginning address. So that last part's the most important. That's where we'll be posting recording of this and those subsequent videos. So let's go ahead and get kicked off here. So there'll be a couple real simple concepts I'm going to cover here. QGIS and OSGeos are a couple acronyms you're going to see a lot, and I'm not going to hit OSGeo very hard at all, but you'll be seeing that around, so I thought it might be worth explaining just briefly what that is. So it's, as you can see from the slide, it's the Open Source Geospatial Foundation, or OSGeo. And very basically, it's a nonprofit organization, and what its purpose is to bring resources together, both developmental and also legal resources together, to try to bring together a lot of, well, just free stuff with developers that are both experienced and dedicated to several different projects, of which QGIS is one. It was formed back in 2006, and as I said, it provides a lot of different purposes, but anywhere from financial to organizational to probably one of the most important things is legal support when you're trying to bring together open source software and you're dealing with several different licenses. And one of those things that, of course, legal helps in is trying to provide open access to a lot of different types of data, some of which is our own data, governmental data, so requests request for data, things like that. And they've got resources to handle that kind of request. Now, QGIS specifically used to be known as Quantum GIS, and I think the Q used to be lowercase. So I've probably got that somewhere in this presentation where the Q is lowercase. But some of you may know it as Quantum GIS from back in the day, I guess. And they describe themselves as a user-friendly open-source geographic information system. And again, just a couple of the just the basics. It's been around for a while, about 12 years. Development began by a guy named Gary Sherman, and it basically became an incubator process or project for OSGeo. So, meaning that it was one of its very first projects, sort of a here's what we can do if we come together kind of project, and that's what QGIS started out as. We're going to use the term QGIS pretty generically throughout this presentation, but if you go to QGIS's website and Wikipedia and all that kind of good stuff, they would probably have us rather calling what we're talking about today as QGIS Desktop, because QGIS actually encompasses a pretty broad range of things that they separate pretty distinctly in all their documentation. So again, what we're going to be talking about today is primarily QGIS Desktop, which if you're going to find an analog to it for existing software that we use a lot, it's a lot like Esri's ArcMap. So you can create, edit, visualize, analyze, and publish a lot of that geospatial information. And Joe will be digging a little bit more into some of the capabilities and the file formats that it accepts, but it's you'll find that it parallels ArcMap's capabilities pretty well. A few of the other things that QGIS is the QGIS browser. So it makes it a little bit easier to browse through GIS information you have both either on a server somewhere or locally, and allow you to move it around a little bit easier. There's QGIS Server, which basically provides the capability to serve out web mapping services, web feature services, and a broad group of other types of information. There's also a QGIS web client. So working in conjunction with the QGIS server, there's the capability to publish maps that you put together as basically a web presentation, sort of a Google Maps style presentation that integrates turning on and off layers, rearranging, opacity, the whole gamut with what you'd expect from a web client and presentation. And then finally, they've just started not terribly long ago with working on QGIS for Android, and you'll see that the capabilities are meant to mimic, in large part, portions of QGIS Desktop, but you can see that last part of the description says it's not for the faint of heart, because it is solidly in beta, and I've downloaded it, and yeah, it's a little rough, but again, it is solidly in beta, and they are looking for feedback from that. So if you're interested and you have an Android device, the bigger the screen, the better. You might want to give that a shot. Last thing I'm going to be covering before handing it over to Joe is platforms. Right off the bat, I mentioned that what got me interested really was trying to find capabilities similar to what I've been used to with ArcMap, and on a Mac or a Linux system. And as it turns out, QGIS is available for about anything you're going to find out there. For the most part, Windows, Mac OS, Linux, BSD, and again, I did mention Android, but that's a little rough. So a broad variety of platforms there that it's available on, and the Windows version I think is primarily what Brian uses, so it's just as robust as anything else, and all works pretty well. So before I turn it over to Joe here, here's a quick sample of some images that I've made up over the course of the past couple of years, just mostly for purposes of personal tweeting out. But this is some of the kind of stuff you can do, and so now I'm going to go ahead and turn it over to Joe to dig in a little bit deeper. Joe?
All right. Thank you very much, Corey.
I'll turn the screen over to you.
Okay. So as Corey said, I'm going to kind of talk about more of the capability of QGIS. And I'm going to go through two demos. And as I go through these two demos, I'll kind of explain some different QGIS features. When you're finished doing this, you probably won't be able to do these, complete these tasks, but hopefully you'll have an idea of what QGIS is capable of. And what we'll be doing is these two demos that I'm going to show will actually be two training videos on our Google site eventually, in a few days, hopefully. So can everyone see my screen?
Yeah, it looks good.
Okay. So the QGIS capabilities, I can't get into every single little feature, but basically QGIS has all the usual spatial analysis tools you would expect for editing and manipulating vector data and raster data. To clip polygons, to edit and move points around, those sorts of things. It also has a lot of capabilities that it can borrow from other open source GIS-related software. So there's actually something called the Processing Toolbox. And what QGIS can do is actually take advantage of the geo-algorithms from other software like GRASS or Saga, which is an open source GIS. So if you're going to use one open source GIS, QGIS is actually great because you can take advantage of all these other tools right from within QGIS. So this is what the interface looks like on Windows. On Mac and on Linux, it's extremely similar. And basically, I'll start from the top and kind of move around. So at the top, there's the tools to navigate around, zooming in, zooming out, zoom to a feature, those sorts of things. Up here on the right, there's other tools that you're probably already familiar with if you've used GIS in the past, such as identifying a point, selecting areas, a calculator for selecting areas, those sorts of things. There's a change projection button to change projection on the fly. That button becomes activated once you start actually adding data. There's your usual vector editing tools up here. This is only just the simple ones for editing shape files, editing polygons and points, but there's actually a lot more that's available besides these buttons. And finally, on the left is the Add Data interface, and I'm going to go through this in a little bit more detail. It looks a little bit overwhelming. When you mouse over it, it tells you what it does, so you don't have to remember what these icons do. I always forget which one does what. But basically, the first two are pretty much going to cover a lot of what you might be using. The first is adding vector data, adding a shape file, for instance. The second one is adding raster files, for instance, a geotip, or it can actually load GRIB2. Towards the bottom, there's actually an option for loading CSV files directly, which I'll show an example of how to do that. And you can see the other tools you can load from a database, you can load from a WMS layer, etc. You can also create a new shapefile or spatialite layer, and of course remove the layers. So there's actually some talk that this might be replaced by a more simplified Add Data button in the future. But for now, there's a lot of options. So in this first demo, which you won't be seeing everything that I'm doing for this demo, but basically I'm going to add some data and plot some points. So the first thing I want to add is a couple of shapefiles. And here are all the vector formats that are supported by QGIS. As you can see, there's definitely a lot. It can support KML, it can support shapefiles, it can support a lot of other ARC formats and other popular GIS formats in the open source and proprietary communities. So what I'm going to do with my demo here is first I'm going to add some shapefiles. I'm going to add a states layer, and I'm going to add a counties layer. And I'm drawing these. I downloaded these from the ALIPS shapefile database website. So that'll become important in a second. So what I did is I added the shapefiles, and you can't see them yet. I'll show you in a minute. But basically, I wanted to change the styles. By default, they'll all come in. Each shapefile will come in as a filled-in polygon or circled point. So for my states outline, I wanted to make it like a thick outline with nothing in the center. So I simply went to the Style menu, and I chose a simple outline, or outline simple line, to adjust that. You can see there's some other options there as well for how to style a polygon. And then for my counties, I wanted to make my counties a little different. For my counties, I wanted to highlight the Goodland County Warning Area, so the area that Goodland serves. So I went in, and I was able to use a rule-based menu option, a rule-based style. So the rule-based style, you can basically build a query, build an expression for how you want a certain thing to be styled. There's a number of options up here, from using math to date and time to the geometry. But for me, I just wanted to use the CWA field within the county layer. I said that when the CWA is GLD, I'm going to use a certain style, and then I made another one that said for everything else, use this style. So what I ended up doing is I made a style where the GLD CWA was colored in with these yellow stars with a blue background. and then the rest of the counties I made clear, basically see-through with a thin black outline. So now that I have my kind of base map, everything looks good, I have it all identified. Now I'm going to add some real data. So what I did is I added the LSRs, the local storm reports from May 2013 for the Goodland CWA and our surrounding CWAs. So you can see, as by default, it plots this shapefile, which is a set of points borrowed from the Iowa Environmental Mesonet local storm report app. It plots these all as points, which is great. So now we know where all the storm reports are. However, there's a lot of different types of reports, everything from snow to tornadoes. And in my case, I just wanted to look at the severe weather, the tornado, the wind, the hail. So what I did is I used the categorize style. So you can see up here, I set it to categorize. For the column to use, I set it to type text, which is the is built in the shapefile that I downloaded from the IEM website for the type LSR. So I classified, and it made all of these different icon colors and for all the different types. I then went through and manually deleted all of the ones but the severe weather, and I also colored them to be more familiar to those familiar with the SPC website. So you can see that here. I made the hail reports green, made the tornado reports red. The thunderstorm wind damage, I made blue dots, and then for the thunderstorm wind gust reports, I actually made little blue arrows. So that looks great. I think that's pretty cool. However, I wanted to go another step deeper, and I wanted to use the size scale field. So I got rid of everything but the hail reports, and I was able to use the magnitude field from the storm report to size, just scale the size of the icons based on the hail size report. So you can see on the map where there's a very big circle, those are big hail reports. Where there's smaller circles, those are smaller hail reports. So that's an example of something I can do. And all in all, including downloading this data, this probably took about 5-6 minutes to complete once you have all your data ready to prepare. So now I'm going to switch gears a little bit, and I'm going to talk about a pretty common task for Weather Service offices, at least, which is creating an inverse distance weighted raster file. So this would be, say you have a bunch of snow reports and you want to plot them on a map. They're irregularly spaced points, and you want to make kind of a gridded representation. IDW is one such technique. So how I did this, I prepared my data in Excel. I took storm reports, I took CocoRoss data. In this case, we're doing a heavy rain event that was in our area. So I downloaded all my data and created it as a CSV. Some websites, like the IEM site, you can actually just download the storm report shapefile directly. But in this case, I had a CSV that I wanted to start with. So once my data was ready, I opened up QGIS, and I opened up a template that I have. You can set up templates in QGIS, which I have heavily taken advantage of. I have one that's just for the United States, a template with a state outline, county outline, those sorts of common things. And that's kind of a shortcut for me when making these maps. So I have my data, and in a CSV, and I'm adding it as a CSV. So I use that Add CSV button that I showed you earlier. And as you can see in this menu, this is the interface for adding a delimited data text file. And in my case, it was a CSV. A lot of this QGIS will actually detect on its own. It usually will detect where the X and Y fields, where the lat and lon fields are. You can tell it if there are headers for your data or not. You can also discard some of the fields. If, say, you just wanted to add the lat, lon, and a value, you can just delete the other fields to save memory and save space. So that's an example of adding the delimited text file. Once I did that, I exported it as a shapefile. Unfortunately, for a lot of the computation, it needs to be added as a vector file. It can't just be a CSV on the map. So I exported it and re-added it to the map as a shapefile. And then you can't see the map here, but basically it was a bunch of points where my rain reports were. So then I used the grid interpolation tool, which is under the raster menu in QGIS. And I used the inverse distance to a power algorithm. And I set up, and I kind of messed around with what kind of a power to use. I think I ended up using 3 for the actual map that I'll show you. But I outputted it to a TIFF file, and then I re-added it to the map. Now, by default, when you add a raster, most GIS software is just going to do it as a black and white color curve. I wanted to do something a little bit more detailed, so I used a precipitation type color curve. There's a lot of color curves actually built into QGIS, and I don't have the time to go into every single one, but this is actually one of the built-in ones. I classified the range of data. I know that it was about like a ½ inch all the way up to about 8.5 inches. So I set the scale from 0 to 9, and I made my map. So once my map was made and it looked good, and I did some other styling to the points as well, I wanted to save it. I wanted to share it with media or share it with our social media. And how I did this, there's two ways you can do this. The first is actually there's a save as image option, so you can actually just take a screenshot of what you've done. So this is what the save as image output looks like. It's basically exactly what you can see on the screen. So there's my map that I made. There's the raster file, and I overlaid the points on there. And you can see the cities, or the states and the county outlines and the interstate line. However, there's a much better tool to making much better looking maps, and that is the Print Composer. And using the Print Composer, I was able to make a much nicer looking map with a title, with a legend. I put a logo on there. There's lots of options with the Print Composer, which Brian will actually show you now. So let me switch over to Brian. All right, Brian, you should have control.
All right. A second here. Okay, so I'm going to go through the Print Composer. Basically, what the Print Composer allows us to do is add elements to the QGIS map, such as text labels, images, legends, scale bars, basic shapes, arrows, the whole 9 yards. So there's a lot of things you can add to your map to really make it look better, improve its readability. You can size, group, align each element individually to really customize your layout. The layout can be printed or exported to various image formats or PostScript or PDF or SVG. So there's a lot of options you can do with it. So here's what the Print Composer window looks like when you bring up a blank, a new Print Composer. And it's going to ask you to go ahead and name this composer, and then you can refer back to it at a later time. So in this case, I've got a blank entry. Some of the items to highlight here are, you've got an option for adding a new map, which is this first option right up here, adding an existing image, so like the watermarks that Joe had in the right-hand corner of his image. You can add text labels. You can add a legend. And what it does for a legend is it looks at the layers you've already defined. So like how Joe defined a color curve for his raster, it would import that. If he was doing the hail, it would take either the color-coded reports for the severe weather reports, or it would take the changes in size for the hail one he did. So it will automatically import that legend for you and then allow you to edit it. And this is just an example of one I threw together the other day that's a final image. And like I said, I put a title up here. I've got a watermark down here. This is a legend that I imported actually from a WMS feed. Then I've got my data, my background, and like I said, you can change the sizes and everything, and then I can export it to an image and share it with other people. So that's the Print Composer, but there's a lot of neat things you can do, like I said, to really jazz up your images before you send them out. One of the other things I wanted to talk about was some available data feeds that we've already got out there to maybe save some people some work to help them make maps quicker and a little easier. I put together a data feed page of all the WMS and GeoJSON feeds we have, and basically WMS, it's web mapping service that returns an image back to QGIS. GeoJSON, that's a vector format and basically returns a vector back to QGIS. So if you get a vector format back, so like we're talking polygons, you get attributes, you can edit it, you can change it, you can change the color, the symbology, all that stuff. With WMS, you basically get an image back and you can't really change it. So, but some of those things will probably save you some time. Some of the sources we have NDFT data, we have RTMA, we have SPC, WPC, and then some observational data. So just showing you how to add a new WMS layer. In this case, I clicked on the item to add a new WMS feed. In this case, it gives you a couple options. You can connect to an existing one, you can make a new one, or you can edit an existing one. In this case, I clicked on my new button, and it brings up a second pop-up where it wants to give you a name and then wants you to give the URL that specifies that WMS feed. And that's where, in just a second, I'll show you with the web page, you would just simply right-click, save that link, paste it in there, and that allows you to add that feed. Then once you connect, it will show you all the options available with that WMS feed. So in this case, I pulled up our minimum RH layer, and you can see there's day 1, day 2, day 3. You could select any of those layers, and then you just simply hit add, and it'll go ahead and add it to your QGIS session. So in this case, I called up the RH from the day 1 NDFD data, and this is the CONUS RH for that. The other option is adding like a GeoJSON feed. In this case, I'm adding a GeoJSON feed. In this, I'm actually pulling it from a web link, but you could also load it from a file that you know, if you had downloaded one or created one on your system. So in this case, once again, I changed my protocol here instead of file-based up here to protocol, and then I picked GeoJSON as the option, and I put in my URL there. And then when I load that into the map, you can see right there, now it's loaded that particular GeoJSON data set into QGIS as a vector field. And I just clicked on one of the elements. I think I clicked on one in Goodland's area, and it shows you all the attributes that are associated with that. So in that case, we've got a color attribute. We've got looks like a start time and end time. You know, various metrics like that. So that just shows you what you can do with vector data and how you can import some of the existing vector data. So you know, kind of wrapping this whole thing up in conclusion. You know, basically QGIS is an open source, multi-platform desktop GIS system. You know, we're looking to make additional training materials to be hosted at the NOAA GIS site, but we really just wanted to kind of introduce it to everybody and give everybody a feel for what it can do. So if you've got specific questions, we'll take those in just a second, but I put up the contact information for Corey Yenitz, Southern Region, for Joe at Goodland, and for myself. And I've also provided a link there to the user documentation, which is a great resource to go back and refer to. So if anybody's got any specific questions, we'd be happy to answer them now.
Yeah, this is Pam from Pleasant Hill. I have actually 2 questions.
Sure, go ahead.
My first question is for geoprocessing, like with Python. Have you guys investigated that? And if so, how friendly is it?
Brian, you're a Python expert, I know. Have you ventured down the road?
Most of the Python geoprocessing I've done has been actually outside of QGIS via external scripts. I know it does support Python very heavily. I have not experimented with that specifically in QGIS. I know it relies on GDAL a lot for some of the stuff, and I know it has the same Python bindings that are available if you're just writing Python code. But I have not actually tried to call an internal Python application, you know, from QGIS directly.
Okay. Because I was going to investigate that. I downloaded this a couple weeks ago and was just wondering if anybody else had looked into it.
Yeah, and one of the things that Corey's played around with quite a bit, and we didn't show today, is the raster calculator. And basically, let's say, so I go and I download NDFD data from NDFD, and of course everything's in the metric units, and I don't want to use metric units. I want to convert everything into Fahrenheit. You can use the raster calculator to do those type of calculations, to change the units, you know, to do a lot of that stuff you might do with Python. So that might be an easier way to do some of that right off the bat, if that's the kind of thing you're looking to do.
Well, actually, we're exporting some of our grids and automating that process to form better-looking maps. So I'm working on that here at Pleasant Hill with ArcGIS, so ArcPy. But it's kind of touchy, so I was wondering if there was a better alternative. My second question was one of the formats that this supports. Does it support GRIB2? or just
Yes.
any data?
Yes, it'll happily read Grid 2 data.
Okay. That was it. Thank you.
This is Corey. I haven't heard this asked, but one thing that that Brian reminded me of that it might be worth mentioning is, you know, a lot like ArcMap, you can save a lot of the things you're doing in template form, basically. So if you've gone into the Print Composer and you've set up basically a map composition that looks really nice to you, and you find you're going to probably be doing over and over again, you can save that composure. And once you've set up another map later on down the road, you can load that same look and feel right back up, and you don't have to mess with it. And so that definitely saves a lot of time. You can do the same thing with the raster calculator. You can save formulas and things like that. So if you've gone through a lot of work to get things to look and feel and work the way you like, it's pretty easy to save and go back and reproduce that within 5 or 10 minutes. A pretty complicated map.
I've got a question. This is Todd in Caribou. Most of us know that ArcMap, maybe isn't the snappiest interface. Is QGIS Desktop any quicker at all? Does it have a quicker feel than ArcMap?
Absolutely. That's actually what attracted me to QGIS, is the fact that it could load up and make a map, and I didn't have to actually wait for anything to load. And in fact, if you're using the latest stable version, QGIS 2.2, it's fast and it's great. But there's actually the next version. You can download the development version now that has it. But the next version will actually have multi-threaded rendering, meaning that each layer on the map will be assigned its own thread for rendering. So when rendering the maps, it can do it very, very fast. So yeah, it's definitely a lot snappier. It's a lot snappier feel than ArcMap.
Great, thanks. It sounds tempting.
Yeah, and I highly recommend. I mean, we can't present every little feature in here. I highly recommend because it's free and multi-platform, and you can try it at your office or even at home. So I use it at home on my Mac, and I love it because it's so fast.
This is Ron at Binghamton. I've used QGIS for a while, but I've built mostly just for point plots. Are you going to make any of these like sort of like a job sheet kind of thing, especially the one that you brought in the CSV data and made a color map of?
Hey, this is Corey. I think it's something worth looking into. I'd considered that. At the beginning, I'd mentioned that we were going to do maybe some short bite-sized videos, but certainly worth talking about. Joe and Brian is maybe shipping that out with maybe a little quick one-pager alongside that to help out a little job sheet like you're talking about.
Thanks.
I have a question that's sort of along those same lines. How about, is there a way that you could launch it from the command line pointing to a CVS file, and it could go ahead and just create the map?
I could probably interject there. I don't know if you caught it on one of Joe's slides, and we could probably back up to show you that. But what it's actually doing is it's calling GDAL Grid, which is basically GDAL is a command line utility. So, and if you notice on Joe's slide, and let's see if I can back up to it to show the slide where he was doing the interpolation. If you look down here in the lower corner, this is actually the GDAL Grid command it's running. So if you've got access to GDAL Grid, basically you could run that you could script that command behind the scenes to do that exact same image generation.
Okay, cool. So you could have like a CVS file get downloaded every hour. Run this command, and your image is created for you.
Right. Now it's going to create one that's like Joe said. It's basically just it's a raster of floats, so you still would have to colorize it or apply a color style or something to that. But yeah, you could have the raster part already done for you.
Okay, great. Thanks.
Just to kind of expand on what Brian was talking about in terms of scripting. So GDAL is, as Brian said, it's like kind of the workhorse of QGIS. It's what's doing a lot of the computation under the hood. And when you script it, there are tools to script it, script everything with QGIS, where you can call the commands that you're using in QGIS, and it's very similar to using the graphical interface, and that's in Python. or you can use the actual tools that it's using under the hood, like you can just use GDAL, which it's mostly using, to create maps and to do that sort of thing. So QGIS is a graphical interface. You can script with it, but you can also script with what it's using under the hood, which is GDAL. And it's not just using GDAL. There's other tools that it's using under the hood. But GDAL is definitely one of the main things that powers it.
What's the benefit of QGIS over GRASS?
It's a pretty interface for QGIS.
Well, I mean, if you need to do scripting and all that, it seems like a lot of this could be done through GRASS, or you download the GDAL stuff and you can do it through GDAL through the command line. So,
right.
How do we decide? I know a lot of the RCs use GRASS still. What's the difference? Why one over the other?
I think it's personal preference, and I think me, in playing with both of them, QGIS was a little more straightforward. I'm not knocking GRASS in any means, but for a lot of the stuff that we're typically doing, I think QGIS is simpler to work with. But like I said, that's personal preference.
Yeah, I think QGIS is kind of good for getting a feel of how to, using the algorithms with GRASS and actually figuring out what settings you want to use, and then maybe if you want to automate things, you can just script it directly with GRASS. But yeah, that is a question that I've come across. Do I want to should I try to script it with QGIS or just go right to the source?
This is John Kennedy in Silver Spring. I heard from somebody offline in another venue that QGIS could interface with GeoServer. And my other question is, can it load and download and modify data on GeoServer as well as the style sheets?
I don't have any experience with that.
It depends on what kind of data you're pulling from GeoServer. I mean, it has the ability, if you're connecting to like a database that GeoServer is offering up, you can modify that. If you have a web feature service set up on GeoServer, once again, if it allows you to write back, you can make edits and write back to it. So it really depends, but the answer is yes, it does allow some of that.
And on the style sheets, I mean, the cartography within QGIS, does it save that as an XML or whatever the style sheet for GeoServer is and be able to upload that?
I'm not sure on that.
Hi, John. This is Micah Wengren. I'm from NOS, but I'm probably the one who gave you that idea.
Oh, okay.
And it's true.
Okay.
There is a plugin. I don't have the information offhand, but there is a GeoServer plugin that was recently developed for QGIS that does some of that.
And so the data would be loaded from QGIS into GeoServer and then modified there?
That's the idea, yeah, and I believe it can translate most styling rules to SLD. And I don't know if QGIS stores, its styling rules internally in SLD. I don't think it does, but there's some conversion capability.
Okay.
Yeah, QGIS can open SLDs and read them, but it saves it in its own XML-based format.
I'd be interested if there's a group of people here at Silver Spring to get together and look at QGIS more directly and exchange ideas.
Yeah, that sounds good to me. I'd be happy to forward the URL. I'll try and track down the plugin for that. I mean, the URL for that plugin to start with.
Along that same line, too, I know I've used QGIS in line with map server as opposed to GeoServer. Style up a layer pretty nice and basically export the map styling configuration and drop it right on our WMS service here, and then it works pretty well. Any other questions out there?
This is Don here. For some reason, just thought I'd ask the question. Are we looking at any point to maybe position QGIS as an alternative to the Esri ArcGIS pay model that we're doing now?
This is Corey. I'm not aware of any effort like that at all. We were really just looking to provide a little bit of an introduction and an alternative, especially for those folks that are working on non-Windows machines or maybe have other situations that might warrant that. But I'm not aware of any effort like that.
Okay. Thanks.
Okay, any other questions?
Hey, Corey, this is Paul McKee at West Gulf. I was curious about whether you could do joins on data types for particular fields.
Yep, there's a broad range of different sort of manipulations you can do with shapefiles, merging, joins, all that good stuff that you come to expect from ArcMap.
Okay. Well, there was a previous question about whether this should be considered over the Esri for desktops, or PCs. But what about within AWIPS? I mean, looks like this could be considered for baseline AWIPS.
Yeah, it seemed like it would be something to definitely be considered. All right. Well, I guess we can go ahead and wrap things up then. I really appreciate everybody's participation. Thanks, Brian and Joe, and thank you all for your questions and attending. And again, Brian had provided some contact information before, so feel free to drop us an email or visit the Google site where you'll find a recording for this and some of our subsequent materials. Thank you all.
Thank you.
Thank you.